So the first rule that you're going to need with matrix operations is called distributive. Just like we said earlier, you're going to take that value and it gets applied to both of them. Does it matter which way if I multiply k at the beginning or k at the end? It does not, right? So you've got it here, so it's k times b plus c. It gets distributed to both. If I look on the other side, I have k at the end. But it doesn't matter which way I multiply. I still have to distribute k to both parts on the inside to get exactly the same result here and here. That's the distributive property. And the bottom line, what I want you to walk away from this with is, whatever's in that group, I take that k and I make it apply to every single part in that group, no matter how many parts it has. That's what you're going to walk away with this from, or walk away with that from. Next part, associative. What does that mean? You remember that? If you associate, how does that apply to math? What would be the rule? It has to do with parentheses. If I had a plus b plus c, does it matter if I add a and b first and then I add c? Or if I associate the last two together? Let's say, what if we added b and c together and then I added a? It doesn't matter. Because you can add in any combination you want to. Do you remember back, I don't know when it was, probably early middle school, when they introduced, well, this may be in elementary for some of you, you talked about subtraction, but when they introduced negative numbers, okay, did your teachers introduce it as adding the opposite? Do you remember that? Not division. If you add, for example, associative is true for addition. Is it true for subtraction? Is 5 minus 3 the same as... If I agree if it was 5 minus 3 plus 6, if I work the way across the board, it's okay. Okay? But be careful if you rearrange numbers, it's the commutative property. 5 plus 3 is the same as 3 plus 5. But when I flip it around, what happens? If I do subtraction, 5 minus 3 and 3 minus 5. Does that hold true? No, you got a sign problem. But what if I said 5 plus negative 3 and negative 3 plus 5? You've taken a subtraction problem and you've gotten around the idea of being subtraction, and you're just saying, well, that's just a negative number, so when I rearrange it, the negative sign goes with it. Then you have commutativity. It doesn't matter which way you look at it. But let's keep going. Scalar multiplication. This is a little different. With scalar multiplication, when you're looking at matrices, this is what's important. If I have two things that are being multiplied together, and then I have a scalar, when I say scalar, I mean, what would you multiply by if I said I want you to double the size of something? What if I said triple the size? What if I cut it in half? 0.5. Okay. Basically you're dividing by 2 or multiplying by 1/2. And so in this case, what I want you to be aware of is when you have two separate matrices that are multiplied together and you've got a number out in front of them, that number will be applied to only one matrix. Don't distribute unless you have plus signs. You distribute to all the terms inside the objects. Does that make sense? You do not distribute like this. Would you distribute here? Would you call that the distributive property? Right. It's just multiply times the one or the other. It doesn't matter which, because you're going to end up multiplying them all together. But multiplication, it's not like the distributive property. You don't do it multiple times. All right, so let's go ahead. This is what you call a matrix. Okay, this is actually two matrices. A matrix. Shh. Don't talk while I'm talking. A matrix has several elements. Up on the board, I have one matrix here and another matrix here. We have two down at the bottom. So in this top part, we're adding two different matrices. The bottom part, we're subtracting two matrices. And so whenever I want to add or subtract, it's very simple. Look at this matrix. Let's just talk about the elements of a matrix. A matrix, in this particular matrix, I have 4 elements.
What is a matrix besides writing?
A matrix is a way of writing out information. So let's suppose that we had this. Let's suppose that you had something like this. A matrix, let's say we had 2x plus 3y, and we had 4x minus 5y. Let's suppose we had that. I can write out a matrix that represents this part of my equation. It would be 2, 3, 4, negative 5. What does the first column represent? Say it out loud. It represents the x's. What does the second column represent? Y's. So what if I said this? Let's add 6x minus 2y and 4x minus y. And I wanted you to tell me if I were to add those like that, kind of in line, what would my result be? So if I change it to matrices, then it looks like this. So 2, 3, 4, negative 5 is the first matrix. Let's talk about matrix in general for a minute. What we have here, this is a 2 by 2 matrix. Every matrix can be described row by column. How many rows are in that matrix? 2 rows going across. How many columns? 2 columns tall. And so my result here will be what? It's going to be 8, 1, 8, negative 6. Anybody want to tell me how I came to that conclusion? I added the first 2 parts, the first x's, then I added the first y's. Right? So if you look at it, 2 plus 6 gives me 8. Come down here, you have, or let's go back to this one, 3 plus negative 2 is 1. 4 plus 4 is 8. Negative 5 minus 1 is 6, or negative 6. Just straight across, keeping all the elements together right along with what you're working on. Right? So that's what a matrix is. That's how you look at it, and that's how you go through with this. I want you to add these 2 equations, or subtract, whichever way it's asking you to do, and tell me what the solution would be. So there's the answer to number 1. The question was brought up, couldn't we just, in order to subtraction, listen, couldn't we just change all the signs and add? Absolutely. If that's the way that your brain kind of works, I don't like that because that means I have to change all the signs. This is a separate step. I just go right ahead and subtract. So we'd say negative 8 minus 1. Negative 5 minus 2. Then 7 minus 8, and then 9 minus negative 2. That one's careful. Got to be careful about. What do you get for the next one? Go across. What's the answer? Guys, it doesn't get any easier than that. Okay? That's addition and subtraction. Okay? Now, it does get a little bit more complex, but nothing difficult yet. Scalar multiplication. I could call this a different thing, but we'll do it first. Go ahead. Work that one out. So once again, matrix scalar multiplication works just like the what rule? Distributive property. Go ahead and multiply it through, and that's it. Now, one other thing we're going to look at is, I'm going to write a problem. Actually, we're going to talk through it first. So listen carefully. I'm going to talk about something, and then you're going to have to write the equation for the matrix. And so here's the situation. This last year you planted 12 geraniums, 36 begonias, 20 petunias. This year you planted 10 geraniums, 40 begonias, 32 petunias, organizing the data using 2 matrices. So, listen, this is the word problem. So here's what we're going to do. I'm going to write mine so that they're vertical columns. And we're going to be like this. So we have, let's say, last week, or last year, and we have this year. So we have begonias, we have geraniums, and petunias. Shh. You should be writing. Okay. Because next time, I'm not going to organize it for you. This is what you have to figure out on your own. I would organize them in such a way that you put one variable across the top, one variable down the side. Okay, last period somebody said, well, couldn't you have done it this week and or this year and last year on the sides and the plants across the top? Absolutely. It would have given you a different sized matrix. It would have been the inverse of what I'm going to be giving you, which would have been fine. So last year for begonias, we had 36. Okay, for geraniums, we had 12. For petunias, we had 20. For this year, we had 40 for begonias, we had 10 for geraniums, and we had 32 for petunias. I want you to write out a matrix equation so that you can tell me the average number of plants per type. What do you think we would do to find the average? Normally, you'd say, let's just add them up and divide by 2. But I want one equation that does that. So let's call this matrix A and this one matrix B. If I write a matrix of all this stuff, it would look just like this. 36, 12, 20. The other matrix would be 40, 10, and 32. What I wanted to do was I wanted to find the average. So what would we do now? I add them. Okay, that's good. Now what else? I'm sorry, we are not allowed to divide with matrices. It does not exist. Multiply by 1/2. There is no matrix division. So you will, if you do not divide, that means you're multiplying by the reciprocal. And you're going to have to make that adjustment. I want you to tell me the average number of begonias, petunias, and geraniums we would have. You do not need a calculator to do this. 36 plus 40, listen, we're going to go ahead and do the addition. So that's going to be 76. That'll be 22 and 52. They're all even. So that's really nice. So when I go to multiply by 1/2 or divide by 2, it doesn't really matter which way you think about it. When you're writing it out on paper, division with a matrix is, you don't do that. Okay, so there's no writing divide by 2. You wouldn't put your matrix over 2. That doesn't make any sense. You would multiply by 1/2. That's why we said that. So when I multiply 76, half of 76 is 38. Half of 22 is 11. And half of 52 is 26. So we would have 38 begonias on average, 11 geraniums, 26 petunias on average over the 2 years. Okay, so back up for a minute. Let's talk about what we did. We wrote a matrix operation. This was A plus B. And we multiplied by 1/2. So if I write it out just like this with symbols, it looks like 1/2 A plus B. And that's what we did here. Questions? I'll explain that later. We good? I'm going to write one. I got a couple more things to look at. So So we haven't done really anything complicated yet. So here's a question. I'm going to write this on the screen. I'm not going to say anything. Shh. And everybody looking up here. I'm going to write an equation. Your goal is to find x and to find y. Do what you've already done today. There's one extra step, but you're going to do at least you can get down to the very last step, and you probably could guess at what to do from there. So here it is. So don't freak out when you see it. Yes, sir.
Have you graded or tested?
Have not.
No, shoot. You already said no. Oh, you did?
Yes.
Are you playing that? What are you doing out there?
Hey guys, get busy on this. So, what do you think you're going to do first?
Distribute 3.
Well, in general, you want to simplify the left side. So I'm going to give you a few minutes to think about that and work on it. I've taken all of that first part, I've condensed it down into this example. Okay, this part of it on this side. We went ahead. Now you could have done it two ways. Let's recap that. You could have done it by distributing first the 3 to both parts, or adding first and then distributing. Okay, that's what we saw right here. Once we got down to this part, we're going to take this part, we're going to set it equal to the part up top. Now, when two matrices are equal to one another, it means that the positions that correspond, like A11, so like this position, is equal to which position? A11. So you're going to set, which parts are important here? I can ignore some parts. Yeah, I don't need an x and I don't need a y. I don't need things that don't have x or y. So this is what we're going to do. 15x plus 9 equals negative 36. And negative 12 minus 3y equals negative 27. If I solve these, you're going to get 15x equals negative 45. So x will be negative 3. Did you find that, Megan? Yeah, you find your negative sign?
Yeah.
And it, the 45. Cool. And so now we're going to add 12 to both sides. You're going to get negative 3y equals negative 15. And y would end up being positive 5. Now we took a long time to discuss that. I gave you time to think about that. In your mind, in your process, once you know what to do, you would have added, distributed, set equal, and solve in probably less than a few minutes. The equal part? So here's a rule. This is kind of universal. When you have two matrices that are equal to one another, you set them all equal. For example, let me just write it out. So we had A, B, C, and D equal to E, F, G, and H. If we have two matrices, I don't care how big they are, but they have to be the same size, like 2 by 2 and a 2 by 2. If the matrices are equal, then what is A equal to? E. What is B equal to? What is C equal to? And D is H. However it happens, go back and look at this. Look at the ones that we didn't use. 15, 15. 3, 3. They really were equal to each other once I simplified everything. So that means that this part, when I find x, must be negative 36. That means this part, whenever I find y, must be negative 27. If it's not, then this is not true. And you may have situations like that. You may have where you come down to negative 5 equals 6. Not true ever. What would my answer be then? Be no solution. Okay? Remember that when when we add matrices, you said earlier that if you add matrices together, they have to be what size? The same exact size. 2 by 2 plus a 2 by 2 works. But a 2 by 2 plus a 3 by 3, what's going to happen? What's going to happen when you do that? So if we had something like this, so 2, 1, 0, 1 plus 2, 1, 3, 2, 1, 5. What's going to happen when I try to add these things together?
They're just gonna be
Leftover pieces, right? I'm going to say, oh, 2 plus 2, 1 plus 1, 0 plus 2, 1 plus 1. Wait a minute. What happened to the 3 and the 5? This is not no solution. This is not even possible. This is never even done. You don't do it. You don't start it. So your answer to a problem like this would be not possible. It's not that there's no solution to it. No solution means that it's a regular equation. I can see kind of how it's working. But the answer, this is one of those where there doesn't have an answer to it. This problem doesn't even happen. This is not possible. Okay? Not possible, or NP. Questions about that? Okay, that's easy to remember. Any questions about this problem? This is about as hard as it gets for now. When you add these together, right? So the question was, why is this one not possible? Because when I add them together, I don't have anything to add to the 3 and the 5. If you add matrices together, they got to have the same number of elements inside each one. This is a 2 by 2, right? This is a 2 by 3. Because they're not the same size, you cannot add them. So if I ask you to do that on a problem, I think your homework has some similar things like this. You say not possible. Move on to the next problem. You want this kind of problem. It's really simple. Questions about this? Good? Okay, so here's your homework assignment. Do what? True. We'll see. All right, homework. Page 41, 1 through 15, all. Write that down real quick.